Hello student, paper number 104, Differential Equation, myself, Hardik M. Pandya, Research Scholar, Department of Mathematics, Maharaja Krishna Kumar Singh Ji, Bhavnagar University, Bhavnagar. Here, this is a partial differential equation of order n. Assume that d is equal to del by del x and d dash is equal to del upon del y. Substitute the value del by del x is equal to d and del by del y is equal to d dash. We get this equation and this is of the form f of d dash into z is equal to f of x comma y. F is function of x and y. Equation number 1. And the general solution is z is equal to complementary function plus particular integral. The complementary function is the complete solution of f of d dash into z is equal to 0. Rule to find the complementary function. This is the partial differential equation. We put del by del x is equal to d and del upon del y is equal to d dash. So we have d square plus k1 d into d dash plus k2 into d dash square into z is equal to 0. We have to find general solution z. Here the auxiliary equation for the given equation by putting the value d is equal to m and d dash is equal to 1. So we get the auxiliary equation, put the value d is equal to m. So d is equal to m. So m square plus k1 m plus k2 is equal to 0. This is the auxiliary equation. First case, the equation has a solution. Here m square plus k1 into m plus k2 is equal to 0 has a solution, and the equation has two distinct roots m1 and m2. Then the complete solution of differential equation, partial differential equation is given by z is equal to f1 y plus m1 x plus f2 y plus m2 x. Here m1 and m2 are different roots of the auxiliary equation. And second case, if the equation has two equal roots, if roots are equal, then f1 y plus m1 x plus x f2 y plus m1 x. When roots are equal, then roots are equal. So we have to consider here x. Z is equal to f1 y plus m1 x plus x f2 y plus m1 x. Here to find the particular integral, consider the equation d square plus k1 d dash plus k2 d dash square into z is equal to f of x y. Here this is of the form f of d dash into z is equal to f of xy. The particular integral is equal to f of xy upon f of d dash. In case 1, if function f of xy is equal to e raised to ax plus by, then particular integral is equal to 1 upon f of d dash into f of x is equal to e raised to ax plus by. Then put the value d is equal to a and d dash is equal to b, we get f of ab. If f of ab is not equal to 0, if f of ab is not equal to 0, then this is solution. Next, if f of ab is equal to 0 and d minus a upon b d dash is a factor of f of d dash, then the particular integral is equal to x into e raised to ax plus by. And if f of ab is equal to 0 and d minus a upon b into d dash whole square is a factor of f of d dash, then the particular integral is x square by 2 into e raised to ax plus by. Next, f of if in second case, if f of x is equal to sine of mx plus ny or cos of mx plus ny, then particular integral is equal to, here this is f of xy and this is f of d dash. This is f of d dash, then f of x upon, here substitute the value d square is equal to minus m square, d dash is equal to minus mn, and d dash square is equal to minus n square. Then we get the particular integral. Next, if f of xy is equal to x raised to m into y raised to n, then 1 upon f of d dash, 1 upon f of d dash into x raised to m into y raised to m, then we can write f of 1 upon, if we have 1 upon x, then we can write x raised to minus 1. So we have f of d dash 1 upon f of d dash. So we can write f of d dash raised to minus 1 into x raised to m into y raised to n, and expand this term in an ascending power of d or d dash and operate on x raised to m into y raised to n term by term. Fourth case, if f of xy is any function of xy, then 1 upon d minus m into d dash into f of xy is equal to integration f of x comma y is equal to we can substitute the value of y is equal to c minus mx into dx. Here this is a factor of f of d dash, and after integration we replace the value of c by y is equal to mx. First example, here we have given the partial differential equation. So to find the auxiliary equation, we taking d is equal to m and d dash is equal to 1. So m cube minus 1 raised to 3 is equal to 1 plus 3 into d minus 3 into m square is equal to 0. So solving this auxiliary equation, we get the roots 1 1 1. This is a repeated root. Repeated root. So f of f1 of y plus x, f2 of y plus x square into f3 of y plus x. Next, solve the partial differential equation. D cube plus 4d square into d dash minus 5 d dash z is equal to 0. Now we write the auxiliary equation by putting the value d is equal to m and d dash is equal to 1. So we get m cube plus 4m square minus 5m equal to 0. Solving this auxiliary equation, we get the root of the auxiliary equation 0, 1 and minus 5. So z is equal to f1 y plus mx. Here y plus m is equal to 0, so this term is equal to 0. So f1 of y plus f2 y plus m is equal to 1 into x. So y plus x plus f3 y plus m is equal to minus 5 into x. So minus 5x. This is the general solution of the equation. Now we have given the partial differential equation. The auxiliary equation is m square plus 1 is equal to 0. So root of the auxiliary equation m is equal to plus or minus I. So the solution of the auxiliary equation z is equal to f1 y plus mx, m is equal to I plus f2 y plus mx, y is equal to minus I. So next, find the solution of partial differential equation. The complete solution is equal to, if here not equal to 0, then we have to find the particular integral. So complete solution is equal to complementary function plus complementary function plus particular integral. Now first we find the auxiliary equation. We put the value d is equal to m and d dash is equal to 1. So we get here auxiliary equation m square plus 3m minus 4 equal to 0. Solving this auxiliary equation, we get the root m is equal to minus 4 plus 1. So the complementary function is equal to phi 1 y plus mx, m is equal to 1, and phi 2 y plus mx, m is equal to minus 4. So this is the complementary function. Now to find particular integral. Particular integral is equal to f of x comma y and f of d dash. Here we have given e raised to 2x plus 4y. So f of 2 comma 4 is equal to minus 36 is not equal to 0. So the particular integral is equal to e raised to 2x plus 4y upon minus 36. The complete solution is equal to complementary function plus particular integral. So phi 1 y plus x plus phi 2 y minus 4x minus e raised to 2x plus 4y upon 36. Next, this is first case. Now here we have given d square minus dd dash into z is equal to cos x into cos 2y. So solution d square minus dd dash into z is equal to 1 by 2. Here we have given cos x into cos 2y. So multiply by 2 divided by 2. Here we know the formula 2 cos x into cos 2y. So cos alpha into 2 cos alpha into cos beta is equal to cos alpha plus beta plus cos alpha plus beta plus cos alpha minus beta. So here cos x plus 2y plus cos x minus 2y into 1 by 2. So the auxiliary equation, putting the value d is equal to m, we get m square minus m is equal to 0. So root of the auxiliary equation is 0 and 1. So complementary function phi 1 y plus x plus phi 2 y. The particular integral is equal to, here this is f of x comma y. This is x comma y and this is d dash, d comma d dash. So here we have to find particular integral. We take this is particular integral 1 and this is particular equation 2. So particular integral 1 is equal to cos x plus 2y upon d square minus d dash is equal to cos x plus 2y upon. In the second case, we know that d square is equal to minus m square and d dash square is equal to minus d dash square is equal to minus n square and d into d dash is equal to minus m into n. So here d dash square is equal to, here m is equal to 1. So m is equal to 1 is equal to 1 minus 1 square is equal to minus 1 minus, this is minus n square, sorry, here d dash is equal to minus m into n. So m into n is equal to 2 into 1 is equal to 2 and minus. So minus plus 2 minus 1 is equal to 1. So upon 1, and here 1 by 2 multiple is 1 by 2. So 1 by 2 into 1 by 2 and pi2 is equal to cos x minus 2y upon d square minus d dash is equal to cos x minus 2y upon minus in m square is equal to 1 minus of minus minus 2 into 1 is equal to minus 2 into minus is equal to plus 2 minus 1 minus 2 is equal to minus 3 and multiply by 1 by 2. So this is particular integral 1 and this is particular integral 2, and the solution and 1 by 6. Z is equal to phi 1 y plus x plus phi 2 y minus x plus cos x plus 2y upon 2 minus 1 by 6 cos x minus 2y. Next, solve d square plus d dash minus 6 d dash square into z is equal to x square into y square. Case number 3, to find particular integral. Auxiliary equation m square plus m minus 6 is equal to 0. Solve the auxiliary equation. We get the two different root 2 and minus 3. So phi 1 of y plus 2x plus phi 2 of y minus 3x, which is complementary function. Now to find particular integral f of x upon f of d into d dash. Now d square common, 1 upon d square and 1 plus d dash, uh, sorry, 1 plus d dash upon d minus 6 d dash square upon d square raised to minus 1 into x square into y square. This is d raised to minus 2 and expand this 1 plus x raised to minus 1, 1 plus x raised to minus 1 is equal to 1 minus x plus x square. So 1 minus this plus square up to into x square into y square. So here multiply by x square into y square in the bracket, we get 1 into x square into y square is equal to x square into y square minus d dash into x square d dash of x square into y square. So d dash is equal to del upon del y into x square y square. We have to remove del by del y, del upon del y. So we have to integrate with respect to y. Sorry, del upon del y. So derivative of y square is equal to 2 into y. So 2 into y upon d minus 6 into x square and d dash square into this, and now again derivative of y. So this is equal to 1, so value is 2 only, plus 2x square and multiply d day square into x square into y square. So second derivative of y square is equal to only 2. Now d raised to minus 2 x square into y square minus here 1 upon d into x square, 1 upon d into x square. We have to remove the derivative. We take the integration, so x cube by 3, and here this 1 upon d square, so 2 times integration x raised to 4 by 12 and x raised to 4 by 12. Here we have to remove d raised to minus 2, so we take the integration with respect to x in the bracket. So double integration of x square is equal to x raised to 4 by 12, and double integration of x cube is equal to x raised to 5 upon 30, and double integration of x raised to 4. We get this, and simplifying this, 2 upon 16 is equal to here 30 and 45. This is the particular integral. The complete solution is equal to CF plus PI. Next, d square minus 5d dash plus 6d dash square into z is equal to y into sin x. The auxiliary equation is m square minus 5m plus 6 is equal to 0. Find the root of the auxiliary equation. M is equal to 3 and m is equal to 2. So the complementary function is equal to phi 1 y plus mx, m is equal to 3, and phi 2 y plus mx, m is equal to 2. Next, particular integral. Particular integral is equal to f of xy upon d comma d dash is equal to y into sin x upon d minus d dash, expand this, d minus d dash into d minus 2 d dash. Now here y into sin x upon d minus 2d dash. Here we consider the factor of the dd dash, and this is the function of f of xy. So solution of this by case 4, we get f of integration of f of x comma a minus 2x. So integration of y is equal to a minus 2x into sin x into dx, where a is equal to y plus mx, m is equal to 2, and d minus 2d dash is the factor of this. Integration this, we get this value. Now again, this is, we consider this is the f of xy, and this is a factor of this. Again this process, this is f of x comma y, and this is factor of dd dash. To solve this integration, f of x comma constant minus mx. So the here b is the constant, so minus comma b minus 3x cos x minus 2 sin x dx. This is the value where y is equal to b minus 3x integration x comma b minus 3x into dx integration f of x minus bx. So this is f of x comma y. We put the value y is equal to b minus 3x, so minus b minus 3x into cos x minus 2 sin x into dx. Integrating this, we get this, and now the way integrating this, we get the constant, and now put the value of b y plus 3x, and simplifying this, we get the solution. This is the particular integral solution. The complete solution is equal to the complementary function and the particular integral plus the particular integral. Thank you.